Picture this. You get in a spaceship right now and you travel at the speed of light, 186,000 miles every single second. Fast enough to circle the Earth 7 times before you finish reading this sentence. At that speed, it would take you over 4 years just to reach the nearest star. It would take 100,000 years to cross our galaxy. And to cross the observable universe, 93 billion years. Except here's the part that breaks people's brains. The universe is only 13.8 billion years old. So how can it be 93 billion light years across? That question is the beginning of one of the strangest rabbit holes in science. And by the end of this video, you'll understand not just how big the universe is, but why how big might be the wrong question entirely. Because the real answer might be infinite. Let's start small and work our way out. Earth feels big. It takes 24 hours to fly around it. But in cosmic terms, Earth is a grain of sand. The Sun is about 1.3 million Earths could fit inside it. Light from the Sun takes about 8 minutes to reach us. Meaning every time you look at a sunset, you're seeing the Sun as it looked 8 minutes ago. Now zoom out further. Our solar system's edge. The Oort cloud, a shell of icy debris surrounding the Sun, is so far away that light takes over a year to cross just that outer boundary. Zoom out again. The nearest star to us, Proxima Centauri, is 4.2 light years away. Voyager 1, the farthest human-made object ever launched, has been flying for nearly 50 years. If it were headed toward Proxima Centauri, it isn't, but if it were, it would still take about 73,000 more years to arrive. And Proxima Centauri is our closest neighbor. This is where most people's intuition already gives out. But we're not even close to done zooming out. Our Sun is one of an estimated 100 to 400 billion stars in the Milky Way galaxy. Not planets, stars. Many of those stars have their own planets, so the actual number of worlds in our galaxy alone could be in the trillions. The Milky Way is a flattened spiral, roughly 100,000 light years across. Our solar system sits in a fairly unremarkable spot, about 2/3 of the way out from the center, in a minor spiral arm astronomers have nicknamed the local arm. Here's a number that tends to stop people cold. It takes our solar system about 230 million years to complete one orbit around the galactic center. The last time we were in this exact position, dinosaurs hadn't evolved yet. And the Milky Way itself is just one galaxy. Step outside the Milky Way and you find more galaxies, a lot more. The Hubble Space Telescope pointed at a patch of sky that looked completely empty. A patch about the size of a grain of sand held at arm's length, found over 10,000 galaxies in that single tiny sliver of darkness. Extrapolate that across the whole sky, and current estimates put the number of galaxies in the observable universe somewhere between 200 billion and 2 trillion, each one containing on average hundreds of billions of stars. Multiply galaxies by stars, and the number of stars in the observable universe is estimated at around 10 to the 24th power. A 1 followed by 24 zeros. That's more stars than grains of sand on every beach on Earth, combined several times over. This entire structure, every galaxy we can detect, every photon of light that has had time to reach us since the universe began, is what astronomers call the observable universe. Its diameter is about 93 billion light years. And this is the point where the math seems to stop making sense. The universe is 13.8 billion years old. Light travels at a fixed speed. So, shouldn't the farthest thing we can see be, at most, 13.8 billion light years away? This is one of the most common points of confusion in all of cosmology. And the answer comes down to one thing. Space itself is expanding. Light from a distant galaxy doesn't just travel through static, unmoving space. The space it's traveling through is stretching as the light moves. So while a photon is spending 13.8 billion years crossing the universe, the galaxy that emitted it has been carried even farther away by the expansion happening underneath it. Think of it like an ant walking across a balloon that's being inflated at the same time. The ant has a fixed walking speed, but the distance it needs to cover keeps growing while it walks. By the time it reaches the other side, that side has moved much farther from where it started than the ant's walking speed alone would suggest. That's why the most distant light we can detect, from just a few 100 million years after the Big Bang, comes from a point that, thanks to 13.8 billion years of continuous expansion, is now roughly 46.5 billion light-years away in each direction. Double that, and you get the observable universe's diameter, about 93 billion light-years. So, the observable universe isn't a contradiction of physics. It's a direct consequence of an expanding universe, and it tells us something profound. The universe is expanding, and it has been the whole time. Here's the detail that changes everything. The 93 billion light-year figure is the size of the observable universe, the part we can even in principle detect. It is not the size of the universe. The observable universe is centered on us by definition. Every observer anywhere in the cosmos has their own observable universe centered on themselves. A bubble defined by how far light has been able to travel to reach that specific point since the beginning of time. Beyond that bubble, there could be more galaxies, more stars, more everything. Just not visible to us because their light hasn't had time to arrive yet, and thanks to the expansion of space, in many cases it never will. So the real question isn't, how big is the observable universe? We have that answer. The real question is, how big is the universe as a whole? And that's where things get genuinely strange. Scientists have tried to answer this by measuring the universe's shape, specifically its curvature. If the universe curves back on itself like the surface of a sphere, it would be finite but unbounded, meaning you could travel in a straight line and eventually end up back where you started, the same way you could walk around the surface of the Earth. If it curves the other way, like a saddle, it would be infinite. And if it's perfectly flat, no curvature at all, the simplest, most consistent interpretation is that it's also infinite, stretching forever in every direction. Measurements from spacecraft like the Planck satellite, which mapped the leftover radiation from the Big Bang in extraordinary detail, indicate that the universe is flat to within a margin of error of about 0.4%. As far as our best instruments can tell, there is no detectable curvature at all. That doesn't prove the universe is infinite. It's possible the universe is finite, but so unimaginably large that any curvature is too subtle for us to detect. The same way the Earth looks flat, if you're only looking at the few miles around you. But every measurement we've taken so far is consistent with an infinite universe. Flat, boundless, going on forever, with more galaxies, more stars, and more of everything, past the edge of what we will ever be able to see. If that's true, then the 2 trillion galaxies in our observable universe, the number that already breaks most people's intuition, isn't close to the whole picture. It's a rounding error. A single bubble in something that has no edge at all. This isn't just a fun fact. It reframes something fundamental about our place in existence. Every star you've ever seen in the night sky, every galaxy ever photographed, every planet we've ever detected, all of it exists inside a bubble roughly 93 billion light-years across, centered on a small blue planet orbiting an average star, in an unremarkable arm of one galaxy among possibly trillions. And that bubble might be an infinitesimally small fraction of everything that exists. We are not just small. We are looking out at a boundary that isn't even really there. A horizon created by the finite speed of light and the age of the universe, not a wall. Somewhere beyond it, in every direction, more universe almost certainly continues, forever unreachable and forever unknowable to us directly. So, how big is the universe really? The honest answer is we don't know, and we may never know. What we do know is that the observable part, 93 billion light-years of galaxies, stars, and everything else, might be the smallest possible answer to that question, not the largest. If you found this as unsettling and fascinating as I did putting it together, subscribe for more videos like this one. And let me know in the comments, does the idea of an infinite universe make you feel small, or does it make you feel like anything is possible? Either way, I'll see you in the next video. Thank you for watching this video, and for more like this, subscribe to Industrial Origin.